tutorial, we are going to learn how we can plot the QCLOUD cross-section in the web model output by using Python. The final outcome of this tutorial will be an image like this, where we have a mountain height and the QCLOUD variables at the shaded regions here. Okay, we started our tutorial today. As usual, we need to import a number of libraries, and I'm not going to detail how for each specific library is, but certainly you can search in Google for more information about this. And then the second step is that we load in the data. We specify the location of our data. For example, I have a data folder right here. And then we also need to open the NestDF file by using the dataset function, which was from the NestDF for dataset. And then after that, we can take out the variables because we would like to plot the cross-section, so that we need to have a fixed longitude or fixed latitude. In this tutorial, I have a fixed latitude at minus 35.9, and the longitude is extending from 145.5 to 150. And the next step is that we need to take out the web variables. I have a z is the terrain, g is the height, and ter is terrain. And then because I would like to plot the cloud water mixing ratio in the WAF, the short name of it is its short name is QCLOUD. We can also print QCLOUD to see more information about it. As introduced in the previous tutorial with the reflectivities, we also use the vertical cross function, built-in function in the WAF to plot the cross-section. Here we specify a number of input for this function, like the QCLOUD is here, and the height and the WAF file name is right here, and then the starting point and the end point. And then we can quickly plot the figure to see how the cross-section of this QCLOUD look like. So you can see here at around 2.5 kilometers, we have a lot of QCLOUDs, and the blank section here is the mountain height, where the QCLOUD is undefined. And we are going to talk more about that in the next step. And the whole of this section is about to fill out the blank page. For example, you can see here it is not very smooth right here. So when we overlay by the mountain heights, there will be certain mismatch between the QCLOUD and the mountain heights. Therefore, we need to use this section of the code to fill out the lowest value of the QCLOUD. And then we plot the terrain height, interpolated terrain heights along the cross-section line to get a smooth line, as we see in this section, in this figure. And then we take out the latitude and longitude by using the lat long coordinates function. Again, this is the imported function from the WAF. We import it here. And then the next step is that we plot the data. We specify the figure by using matplotlib. We plot the QCLOUD contour by using the contour f function in the matplotlib. There's a certain number of input that we need to supply for this function, but you can search for it in the website. And then after that, we also need to add the color bars here, and we fill out the mountain area. It's similar with the previous tutorial when we talk about the reflectivities, and also a number of other parameters such as the label and the title. So we can see here we have the height in meters. Now it's just only from 0 to 500 meters, 5 kilometers. But in the original plot, it was from 0 to 20 kilometers. But there is nothing above 5 kilometers, so we need to cut it off. And in order to do that, it is very simple. We need to specify by using this function. And then as you can see here, the current value is, because it is defined at each grid point, so that the line here is not very smooth, and all of the below here is either 0 or non-defined value. Therefore, we need to use the function interpolate function to get the smooth pattern like this in the figure. And yeah, this look nice. And compared with the previous reflectivities, we can see that Q-ran is contribute more for this reflectivities rather than the second one right here. It is interesting. And okay, it's all done. Thank you very much for watching, and please feel free to let me know if there is any other analysis that you would like me to do, and please subscribe my YouTube channel too. Thank you very much.